Here's a brief description of how stylus displacement is detected in the Phaedrus Audio DisC cartridge. The essential concept behind the new cartridge is to operate an electrodynamic cartridge as a displacement-sensitive current generator rather than as a velocity-sensitive voltage generator, the latter being the normal approach. Here's a picture of the equivalent circuit of the electrodynamic cartridge, in which a voltage generator feeds a complex internal impedance comprising a resistive component R and an inductive component L. In this introduction, we're going to ignore the effect of the small resistance R and concentrate on the large inductance L. Normal operation of the electrodynamic cartridge is that the open circuit voltage is developed across a resistor which is substantially greater in value than the resistive component of the pickup. It is this voltage signal which is normally amplified by the RAAA preamplifier. How does this work? Well, Faraday discovered that the voltage generated in a coil of wire in a magnetic field is related to the rate at which the magnetic flux changes. In a phono cartridge, the changing flux will thus depend on the velocity of the stylus, because it's the stylus movements communicated by the cantilever which alter the magnetic field strength by moving one part of the generator relative to the other. The coil relative to the magnet in a moving coil, and the magnet relative to the coil in a moving magnet type. Simply put, more voltage is generated, the faster the stylus moves. Now that expression is called Faraday's law, and d phi by dt just simply means the rate of change of the flux. So E is related to d phi by dt. In a normal electrodynamic phono cartridge, the magnetic field is dominated by the proximity of the permanent magnet relative to the coil. So we can take flux phi to equal P, position. So we can recast Faraday's law in terms of position and ignore the direction convention for convenience. And we can say E equals dP by dt. This equation is at the heart of the velocity-sensitive pickup. It's according to this relationship that all moving magnet and moving coil cartridges operate. An electrodynamic phono cartridge may be made displacement sensitive if the short circuit output current is sensed rather than the open circuit output voltage. To see what happens when this EMF is forced to circulate in the coil of the cartridge via the short circuit, we need the current voltage relationship in an inductor, which is given by this expression. Note that this equation includes a time integral, that's the long S with the dt after it. This is the reverse of differentiation. We don't need to think about much more than just remember that that's the reverse of differentiation. Now we can substitute our version of Faraday's law, E equals dP by dt, into this equation, since we have the expression for E. And we get that. But note, although this looks horrible, that we have an integral of a differential. And these things cancel out. And we're left with the very simple expression of short circuit current equals position over inductance, or more generally, short circuit current is directly proportional to position. Now, it's one thing to have a circulating short circuit current which is a measure of stylus displacement, but we need to get that signal out, and that is the role of the transimpedance amplifier, which samples the short circuit current and acts to all intents and purposes like a preamplifier, albeit a preamplifier without the normal RAAA equalization. The Phaedrus Audio transimpedance preamplifier is called the Fathom, and this is the partner of the DisC cartridge. This is an interior view, and this the exterior.